This is a video on Redux, and you might be asking yourself, why Redux? Isn't it completely outdated? Who even uses this library anymore? Actually, there are two reasons. The first one is that Redux is still the most used state management library by a large margin. It is 8 times more used than its biggest competitor, which means for you that if you apply for a job, there's a very high likelihood that your future employer requires you to know Redux. The second reason is that Redux teaches you clean code patterns that you can't learn otherwise, or that are hard to learn otherwise. If you're a seasoned developer, you might be saying right now, no, Redux is so boilerplatey, it's not clean at all, and it is a little verbose, but at the same time, when you isolate your side effects with sagas, when you compose your selectors, it is actually very deterministic, very modular, and very, very testable. And this video is part of a 5-video series on Redux, taking you by the hand and teaching you everything that you need to know about Redux. And in the end, you're also going to build some real-world applications using Redux. I've actually built Redux apps that scale to hundreds of thousands of users, and I'm going to share with you all the secrets that I learned in that process. The first question that most people ask themselves is, why Redux? Or why did it become so popular? And also, why did it fall off? But in order to understand the answers to these questions, you first need to understand Redux. So the first question that you're going to start with in this video is, what is Redux? Redux is a state management library where all of your state lives in a centralized global store that all of your components have access to. And the word Redux comes from the array reduce method, and it comes from the Flux architecture. The Flux architecture consists of a model, of a view, and a way to update your state, and then your data flows circular. And Redux has 6 building blocks. You've got your actions, you've got your dispatch method, you've got middleware, reducers, a store, and selectors. And here's how they all work together. Your users obviously interact with your components. And when they click, then an action is dispatched, or when they scroll, or when they type, right? So basically, different user interactions trigger different actions. And actions can also be dispatched based on asynchronous things that happen. For example, a fetch has succeeded or a login succeeds. And then once an action is dispatched, it flows through your store into your middleware. And the middleware can modify the action. The middleware can also trigger asynchronous things like fetching more data or something like that. And then once the middleware is done handling your actions, the actions flow into your reducers. And your reducers then update their corresponding state, their corresponding piece of substate based on the action. And once your state has finished updating, then the selectors funnel the data back into your components, triggering a re-render. This video contains many code examples, and I highly recommend that you code along so that you retain the most knowledge. Start by creating a new Next.js project. Hit yes to every option except for TypeScript, because the third video in this series will cover how to set up Redux with TypeScript. You should know the basics of JavaScript, like for example, what an object is, and you should know about array methods such as the reduce method. As a refresher, the reduce method takes in an array and it takes in a callback function. And then this callback function is called the reducer function, and it's applied to each element in the array to produce one final output value. Here's an example how to sum an array of numbers. The reducer function takes in an accumulator, in this case called total, and the current value. If this was too fast for you, then watch this video that explains array methods to you and some more advanced functional programming concepts that you need to know later for this video to understand advanced selector composition. I've linked it for you in the description below. And now let's start breaking down all of the building blocks of Redux, starting with the action. The action object is the only way that your app is going to communicate with your store. Actions are plain JavaScript objects and must have a type property. The type property indicates the action's purpose. They can also have an optional payload, and the payload can be any type in JavaScript. The save sponsor action represents more of a real-world action because the type has an actual purpose, and the payload here would be the sponsor that you want to save. And talking about sponsors, this video is sponsored by my company React Squad. If you need to hire senior React developers, click the link below the video now. And then the next building block that you're going to learn about is a reducer. Reducers are pure functions that take in the current state and then an action, and then they return the new state. State is the accumulator and action is the current value. When you write reducers, you usually use a switch statement which evaluates the action's type. In this example, the reducer function handles 2 action types. Increment increases the state by 1, and increment by increases the state by the amount specified in the action's payload. The default case returns the current state unchanged, which is important for handling any unknown actions. Remember, your reducers must be pure functions. That means they do not modify their inputs, they do not perform any API calls, and they do not generate random values such as with math.random or any new dates. And each case in your switch statement must use the return statement to prevent your switch cases from falling through. To use your reducer, you can create an array of actions which lists the actions to process. Now you can reduce over your actions, passing in your reducer as the reducer function and 0 as the initial value for the state. The result is 9001. This usage example visualizes the reducer part in the name Redux. Capture the initial state in its own variable to improve the code. This lets you easily use default parameters for the initial state and add a new action to reset the reducer to its initial state. You can test it by adding it to your actions array, and instead of hardcoding 0, you can pass the initial state to the reduce method. This prevents errors if you ever change the initial state. Now the result is 42. But you can improve the code even more. Create factory functions for your actions. These are known as action creators, and if an action creator needs a payload, pass it as a parameter to your action creator. Replace the hard-coded actions in your array with calls to these action creators. You pass the numbers as arguments to the increment by action creator that needs a payload. After these refactors, the resulting state should remain the same. Here are the benefits of using action creators. Action creators reduce boilerplate by abstracting away the creation of the object and type, so you can only focus on what actions to call and its payload. And as factory functions, action creators allow you to do calculations on input. For example, you can provide default values through default parameters, which also gives you type inference for free. Action creators decrease bugs by encapsulating the type constants in your reducer file. Can you clean this code up even more? Yes, you can. Now you're about to learn some senior secrets to structure your Redux code. First of all, add a slice. This is nothing senior yet, but a simple step that prepares your code for correct usage in your Next.js app. A slice refers to a specific portion of your application state. Each slice is responsible for a distinct feature or domain within your app. It includes its own reducer, action creators, and selectors. Next, destructure the type and payload of your action and default it to the empty object. Destructuring reduces the amount of code you need to write in your switch statement. Also, tightly couple your action creators directly to your switch cases by using the action creator's type property instead of hard-coding strings. This approach prevents typos in your action types and makes refactors easier because changes in your action types automatically propagate to your reducer. To keep your reducer a pure function, you create new objects using the spread syntax instead of modifying the current state. Keeping your state immutable makes your state updates predictable and helps with efficient rendering updates. And the second reason why you're spreading here is because you only want to update the count property. So if you ever add additional pieces of state to this substate, then you only update the count variable and all of the other properties remain unchanged. Your refactor has one final benefit, which is that if you now import your reducer anyway, you can call it without arguments to get its initial state, which can prevent bugs that can come from importing the wrong initial state. Now you're going to learn about the third building block, the store. The store is where your reducers and your middleware is wired together. Here's what an example implementation of a create store function looks like. All of your application state is encapsulated in your store, and the only way to read from your store is using the getState function, and you're using Clojure to achieve the data privacy here to avoid anyone manually mutating your store without using the Redux API. Now import your create store function to create your store. Call your reducer without arguments to get your initial state, which in your case is just an object with a count property that has the value 0. And then you can use the getState method to access the current state of your store. Now you want to replace your custom implementation with the implementation of the create store function from Redux. So install the Redux package. You're going to use the legacy create store import because the regular create store import is deprecated. This function is deprecated, but don't worry, the only reason why it's deprecated is because the maintainers of Redux want to nudge you to use Redux Toolkit instead of setting everything up manually. And the third video in this series is going to show you how to use Redux Toolkit, so make sure you subscribe to the channel so that you get notified when it releases. Now, how do you send actions to your store, you do that using the dispatch method. So go back to your custom implementation of your create store function and modify it to support a dispatch method. Dispatch takes in an action and uses the reducer from your create store function to calculate the next state and then mutates the state in the closure. The store that you created using the create store function from Redux already has a dispatch method. Define an array of actions using your action creators from your example reducer. Then use a for loop to dispatch each action to the store. After that, calling getState will give you the final state of your store. You have learned how to set up your store with a single reducer. But in a real-world app, you're gonna have multiple reducers, each reducer corresponding to a specific feature or domain of your app. So how do you set up your store with multiple reducers? To do that, we need a second reducer. So create a new user profile reducer. Create two actions, one for when the user logs in and another for when a list of users is fetched. You want to normalize the state of your users, which means that instead of saving an array of users, you're going to save an object of users where each key is the user's ID and then the value is the actual user. On the screen right now, you can see an example how that looks like. So pay attention to that each key is the user's ID and then the value is the actual user object. Why do you want to have a normalized state? Well, that makes it easier for you to update any specific user. In an array, you have to filter through the array and find the right user, which can cause performance issues, especially when you have lots of users saved locally. But for an object, you just access the right ID, you just access the right key. And the same goes for when you want to update a user. Instead of having to replace the specific user in the array, you just go ahead and find the user with the correct ID and just update that value because objects override their values by default. Always create a new object when updating the user's object to maintain state immutability. You're going to create two actions. One for when the login succeeded and one when all of the users have been fetched. Notice that you name your action creators in past tense. You do that because that allows you to pinpoint the source of bugs if something goes wrong. So imagine that you have two ways to change the current user. One, when your user logs in, and the other one, maybe there's a feature in your app that lets them switch accounts if they have multiple accounts. If you were to only use one action called setCurrentUser, then you would dispatch it from multiple places in your app, and if something goes wrong, you didn't know which feature caused the bug. But if you use distinct actions for the distinct places where the action can be dispatched, even though they trigger the same state update in your reducer, then that allows you to pinpoint the source of your bug. Another advantage is that if multiple actions cause the same state update, you can use a helper function to abstract away that state update so it's always exactly the same, and if you modify it, it automatically gets updated for all of the actions that should cause the same state update. Notice how each of the switch cases has their own return keyword. You want to do that to avoid fall-through cases because that can cause unwanted bugs. Now import both of your reducers and their slices into the store file so that you can learn how to hook them both up for your create store function. Then create a combine reducers function. The function merges several smaller reducers into a single reducer that manages the overall application state, usually called the root reducer. Each reducer passed to combine reducers handles its own part of the state, which is defined by their respective slice key. When an action is dispatched, combine reducers calls each reducer with their respective state slice and the current action, and then it merges the result of all the reducers into the final state object. And you might be asking yourself right now, but what if a reducer gets passed an action that it's not meant to handle? Well, because there's no case in the reducer switch statement, it just ignores the action. Use your combine reducers function to create a root reducer and modify your store to use that root reducer. When you call getState, you can see each slice and its respective state in the store's current state. Now replace your custom combine reducers function with the combine reducers function from the Redux package. Instead of using your store directly in your UI components, Redux usually uses UI binding libraries. And the official one for Redux is called React Redux, and it's maintained by the Redux team. React Redux does certain optimizations. For example, it only triggers re-renders of your components if necessary. Install it in your project now. Then create a make store function and get rid of your store object. The reason that you create a make-store function is because Next.js can handle multiple requests at once, and you want to avoid sharing the same store for all of those requests. If you're using a single-page application, for example with vanilla React, then it's totally fine to just create a store object and use that. But in Next.js, that could cause all of your users having access to the same store, which you want to avoid, especially if there's sensitive data that should only be accessible to a certain user. Now, use your make-store function in a store provider that you're going to wrap around your app. Use a ref to ensure that the store is only created once. Although the component only renders once per server request, if there are other components on the clients that are stateful and they change their state, that might cause additional re-renders. Then, pass the ref of your store to the provider from React Redux. You want to use your store provider at the highest point of your component tree to where all of the components live that need access to your store. In this tutorial, you're just going to throw it into the root layout. So import it in your root layout and then wrap it around your root HTML tag. If you only need to access your store from certain routes, then simply use your provider only in the respective page or route layouts. Now, how do you get data from your store into your app? That is where selectors come in. Selectors take your whole Redux store and return a little bit of a part of it or just an aggregated value. For the following examples, you do not need to code along. I'll let you know when it's time to code along again. Remember, after merging your reducers into one using combine reducers, you can dispatch actions to change your state. This code example shows you how to dispatch actions to create a state with a count of 10 and 2 users in the user profile slice. One is the current user, who in a real-world app would be logged in through the browser. Now you can write a select current count selector that takes in the state and returns the current count. And if you wanted to write the selector to grab the current user's email, you can write a selector for that too. You can use the normalized state to easily access the current user object and retrieve the email using optional property access. It's best practice for your selectors to always return the same data type with meaningful default values. If the user is undefined, the optional property access returns undefined and the nullish coalescing operator will return an empty string. This ensures your selector always returns a string. Selectors can also take in arguments and aggregate values by computing values from your state, transforming it, and filtering it. Here's an example of a selector that both accepts a user ID as a parameter and derives the user's full name by combining their first and last names. If no user is found, it returns user not found, providing a meaningful default value. If you try to render a non-existent user's email, it will display user not found instead, which offers a better user experience than showing nothing or causing your app to crash. There's a lot more to learn about selectors, but the best way to learn those benefits is in context. And for that you need to learn how you can connect your React components to Redux. React Redux offers 2 APIs for this. First, hooks, and second, higher order components. You're going to see the hooks first. Now it's time to code along again, so create a file that will contain your Redux hooks. Create 3 hooks using the withTypes method from the respective hooks from the React Redux package. And if you want to use Redux hooks, use these throughout your app instead of the plain useDispatch and useSelector hooks, because these hooks have better type safety. Now modify your page.js file to get the current count from your state. You'll have to use the useClient directive here too, because only client components have access to the Redux context. Import the useAppSelector hook and inline the selector function to get the current count. You wrap your root layout with the Redux store provider, which then gives access to all of the components below it in the component tree to the Redux context, which in turn gives access to the store, the state, and the dispatch function. The useAppSelector hook takes in a selector as its callback function and then passes the state to this callback function as the first argument. Remember, you can only use the useAppSelector in your React client components because server components do not have access to hooks or contexts. Now, whenever the returned value from useAppSelector changes, the home component will re-render. However, it's important to understand that useAppSelector actually memoizes its value. That means it only triggers a re-render if the value changed as compared by a strict equality comparison. If you want to learn more about memoization, check out useCallback versus useMemo, which breaks down memoization in depth and how it relates to React. useAppSelector uses useCallback behind the scenes to trigger the re-renders. And remember, useAppSelector takes in a selector as its callback, and a selector is a pure function that takes in the Redux state and returns a derived or aggregated value. Define your first selector, called selectCurrentCount, below your example reducer. Saving your selectors as a variable like this is actually better than defining them inline. The reason for that is that if you define your selectors inline and for some reason your state changes, then you need to update your selectors everywhere where you inlined it. But if you just save it as a variable, then you only need to update it in one place and all of the reference to it can stay the same. Now go ahead and use your selector in your home component. Import your selectCurrentCount selector and pass it as a callback to the useAppSelector hook. You will learn more about the benefits of saving your selectors as variables as opposed to inlining them very soon. But first, you need to find out how you can modify your state from your React components. For that, you're using the dispatch function that you learned about earlier, and you can get access to it in your components by using the useAppDispatch hook. The useAppDispatch hooks returns the store.dispatch method, accessing it through the Redux context provided by your store provider. Then you can dispatch your action creator. In this example, you're going to dispatch the increment action when a user clicks a button. Clicking the button will update the state and then automatically change the count value that your component receives, which triggers a re-render and updates your user interface in the browser. Now, the second way that you can link your Redux store to your components is using the connect higher order component. A higher order component is a function that takes in a React component and returns a React component. If you don't know what that is, go watch this video now, which explains higher order components to you in detail. The link is in the description. Now, go ahead and remove the selectors from your file and instead import the connect higher order component. Modify your page component to accept the count and increment functions as props. The connect higher order component from Redux links the Redux store to the React component. It takes in two parameters. First, mapState2props is a function that defines how to transform the current Redux store state into component props. In this case, it uses the selectCount selector to define the count prop. mapDispatch2props is an object that defines which action creators to pass to the component as props. Notice that you do not have to wrap increment with dispatch because mapDispatch2props does that automatically for you. The increment function that your component gets passed in through its props is different from the increment action creator that you import. When two variables have the same name, it's called shadowing. In Redux with the connect hook, shadowing can happen. But don't let this confuse you. The increment action in the props is wrapped with dispatch, so when you call it, the increment action is sent to your store. There's also a third parameter for the connect higher order component called merge props. It allows you to mix the props from Redux with the props passed to it from its parents components. It is rarely used, so it is enough for you to know that it exists, and if you ever encounter it, you can look it up in the documentation. Now, let's talk about the real benefits of selectors. Earlier in this video, you set up two slices, the example slice and the user profile slice. And the first reason for that is so that you can learn about combine reducers. But the second reason is that only a sufficiently complex slice, like the user profile slice, can show you all of the benefits that selectors have. So, create some selectors in your user profile slice. The select user profile slice selector retrieves the user profile slice of the state. Select current user's ID gets the current user's ID from the user profile slice. Select users returns the user's object from the user profile slice. Select current user retrieves the complete data of the current user. Select current user's email returns the email address of the current user. Select current user's full name returns the full name of the current user. Finally, select is logged in checks if the user is logged in. Now that you've seen a bunch of selectors, you're ready to learn the real benefits of them. First, selectors are facades that abstract away state shape dependencies. And second, selectors are memoizable. A facade is a design pattern where you provide a simplified interface to a complex subsystem. And you've got state shape dependencies when the code that you write is dependent on the shape of your state. In other words, you cannot change the state shape without breaking the dependent code. And state shape here means the content and the data type of your state. For objects, it refers to the nesting structure. Here's what your current state looks like. Your users are normalized, and each user is saved in an object where the key is their ID and the value is the complete user. Now imagine that for some reason you would need to refactor your state shape so that instead of your users being normalized, they are now in an array. If you would have inlined your user profile selectors, you'd need to update them in every component to support the array by using the .find array method. You would need to update your selectors everywhere where you're using the users or any derived state from them, like the current user's email. And for all of the selectors that you define in a variable, if you do that state shape change from normalized users to arrays, you'd also need to update all of them too. Here's how that refactor would look like. After the state change, you'd need to update the three selectors that access the current user. Select current user, select current user's email, and select current user's full name. All of these selectors now need to be changed to use find. There was also a hidden change. Select users now returns an array instead of an object. But arguably, this was the only intentional change. All of the other selectors should still return the same, but they had to be refactored to do so. This shows you that the code for the selectors violates one of the most important design principles in software. In the book A Practical Handbook for Software Development, it is written that a small change in requirements should necessitate a correspondingly small change in the software. Luckily, selectors have another key feature. Your selectors compose, which is the key property that allows them to abstract away state shape dependencies. Now, assume you're back to the normalized state, then you could write your selectors using function composition like this. Select current user's ID and select users can both use select user profile slice. Select current user can use select users and select current user's ID to easily return the current user. Now, select current user's email and select current user's full name can both use select current user under the hood. Finally, your select is logged in selector can also use select current user's ID. As you can see, all of your selectors are cleanly abstracted away. They only add what is necessary about their specific piece of state, which is specialization, and they hide what is common to all of the selectors, which is generalization. Now imagine you would have to do the refactor again from the normalized state to the array state. You'd only need to change one line in the select current user selector. All other selectors could stay the same. It should be clear to you now why people say that selectors abstract away state shape dependencies. Because if you're composing your selectors like that, you only need to update the one selector that corresponds to your state shape change if your state shape changes. But if you're using uncomposed selectors and your state shape changes, then you need to update multiple selectors, which increases the chance of bugs. The second benefit of selectors was that they're memoizable, and if you're familiar with memoization, it should be obvious to you why selectors as pure functions are easily memoizable. But if you're unfamiliar with memoization, go watch this video now and then come back to this video to learn about the other parts of Redux. There's also another API called createSelector, which only the third video of this series is going to tackle because it's exposed by Redux Toolkit and its purpose is to memoize selectors. Now, this video promised you to get a senior understanding of Redux, and the truth is that you can increase the code quality of your selectors even further. Rewrite your selectors using functional programming. You're going to use 4 functions. Prop retrieves the specified property from an object. This is useful for accessing specific slices of the state directly. Pipe combines multiple functions into a single function that executes from left to right, passing the return value of each function to the next. Converge accepts several transformations and a combining function. The transformations gather data from state, and the combining function merges these pieces of data. Prop OR is similar to prop, but it provides a default value if the specified property is missing in the object. All of these functions are curried, and you're going to use them using partial applications. Now use them to rewrite your selectors. You can rewrite select current user profile slice using the prop function. Then rewrite select current user's ID using pipe and the prop function. Next, rewrite select users using pipe and the prop function too. Then you can rewrite select current user using converge and the prop function. Then rewrite select current user's email using pipe and prop or. Next, you can rewrite select current user's full name using pipe, converge, and prop or. Lastly, you can rewrite select is logged in using pipe and the Boolean constructor. Your selectors still behave the exact same way, but now their code is more declarative. Over time, it will get easier to read and write this declarative code, and it will become more intuitive than the old imperative ways. If this code went over your head and you're unfamiliar with functional programming in JavaScript, watch this video that explains functional programming in JavaScript to you. The links to all of the videos I mentioned are in the description. I know this video contains many plugs to other videos, but Redux is really only understandable at the highest level if you have certain foundations. So I'm trying to provide all of those foundations for you so that you can then write the cleanest and highest level code. All helper functions are available in Render, so install it. Then delete your custom helper functions and import these helper functions from Render instead. You can refactor the selector for the counter using functional programming too. Here you also use prop to access the different slices and pipe to compose your selectors. The connect higher order component works exceptionally well with a design pattern called the display container component pattern. This pattern has fallen out of favor in the broader React community, but I still like it very much, and old Redux code bases have a high likelihood of using it, so I want to teach it to you. Basically, you organize components into two different types. First, you've got your display component, which just takes props and returns JSX. So all display components are pure functions. They do not contain any logic or side effects apart from simple ternaries and mappings. And then you've got your container component, which contains all of the logic and your hooks and your states and your use effects, right? And they also contain very little JSX, if any at all. Create your first display component for a user profile. The display component for the user profile takes in a isLoggedIn Boolean and renders the email for the logged in user, or a button that, when clicked, logs the user in. For the sake of this tutorial, the details of the user are hard-coded. With the series of selectors out of the way, you can now combine all of your selectors and action creators for your user profile together with your user profile display component in your user profile container component using the connect higher order component. The connect function connects the Redux store with the user profile component. It uses map state to props to subscribe to Redux store updates via selectors and map state to component props. It uses map dispatch to props to bind action creators to the Redux store dispatch, allowing the component to trigger actions. Notice how this user profile container file doesn't contain any JSX. Now import the user profile container and render it in your home component. If you run your app now, you can click login and then see the user's email displayed in your user interface. Warning, there will be a difficulty spike here now, but you can relax because this video will break down every single step for you. So now you're gonna learn about the last building block of Redux called middleware. And you're gonna learn middleware by looking at two examples, logging and fetching data. So imagine you wanna debug your app and you wanna log out every single action that gets dispatched as well as the state after the action has been processed. To do that, you could create a function called dispatch and log that takes in a store and an action and then logs out the action as well as dispatches the action to the store, and then it finally logs out the resulting state after the action has been processed. You can import this wrapper function in some component together with the new use app store hook that you set up way earlier in this video. And then you pass the store and the action that you want to dispatch to your wrapper. When you run your app now and click the button, it will log out the action and the state after the action has been handled. Now to the second case, which is fetching data. Fetching data in Redux is frequently done using something called thunks. A thunk is essentially a subroutine that adds additional calculations to another subroutine. It delays the computation until it is needed and can also add in additional operations at the point of execution. In this example, truth is calculated immediately, but you can also define it where the calculation is delayed after you call a function, which in this case would be the thunk. Now, the term thunk was coined by its inventors in a late-night coding session. They realized that certain things can be pre-computed or have already been thought of, and they jokingly said that thunk is the past tense of to think. You've learned that all Redux actions are objects, but with the Thunk middleware, also functions can be dispatched from your components. And these thunks can then either handle asynchronous operations like fetching data or dispatch even more actions. When an action is a function, you call it a thunk. In Redux, thunks are higher order functions that return another function. This returned function accepts the dispatch function as its first parameter and the getState function as the second, and returns a promise that results with nothing. It gets access to these arguments from a wrapper, which you will see in a second. Your fetchData thunk handles asynchronous API calls. It dispatches different actions depending on whether the fetch has started, succeeded, or failed. Here is how you might write a manual dispatch async wrapper to handle thunks. This dispatch async function checks if the provided argument is a function. If it is, it assumes it's a thunk and calls it with the dispatch and getState methods from the store. Otherwise, it dispatches the action object as usual. You can use the dispatch async wrapper function in your component to handle the fetchData thunk. You simply wrap the dispatching of the fetchData thunk with dispatch async. Now, when you click your fetchData button, the dispatch async wrapper function checks if the fetchData thunk is a function, which it is, right? So then it passes the dispatch function and the getState method to that thunk. The thunk then handles the fetching of the data and then dispatches actions based on the fetch result. Now, you can compose both of your wrapper functions to prove that your thunk wrapper works through the logging wrapper. Inside the onClick handler, you call dispatch async. Instead of passing the thunk directly, we pass a function that takes dispatch and getState. You create a dispatch with log function that wraps the store's dispatch with dispatch and log. You then return the fetchData thunk, which is immediately invoked and returns its async inner function. This inner function is then being called with dispatch with log and getState. By doing this, every action dispatched within the thunk will go through dispatch and log, which logs the action and the next state. Here's what gets logged out when you now run your app, click fetch data, and the fetch succeeds. If it fails, the following would be logged out. You can imagine that importing these wrappers everywhere and then also having to compose them is very inconvenient. Additionally, you'd need a new wrapper for every new requirement. Middleware offers an easier solution. Middleware intercepts your action after they've been dispatched, but before they reach your reducers. Middleware and Redux are curried functions that first take a store object, then a dispatch function, also called next, and finally the current action. Middleware returns a function that takes an action and optionally returns a value. This value is usually the next middleware. This is what a logger middleware would look like that solves the previously mentioned use case of first logging out the action and then the state after the action has been processed. But there are many more middleware. To understand how middleware works, you need to first see the apply middleware function. Apply middleware comes from Redux and it's essential for running your middleware. You need to wrap the apply middleware function around all of the middleware that you pass to your store when you pass it to your create store function. And the best way to understand how apply middleware works is by creating your own version from scratch. So create a new file that will contain your apply middleware function and a modified version of your create store function. This file will be completely self-contained and only for demonstration purposes. I will tell you later how you need to modify your existing store file so that you can use the apply middleware function from Redux. Apply middleware is curried and takes in any number of middleware using the spread operator, so you have access to an array of middleware in the function body. It returns a function called enhancer that takes in your create store function, a reducer, and an initial state. These arguments will be passed to the enhancer from create store, which you will see in a minute. It creates a new store using your create store function. Then it creates a middleware API object that exposes a getState method and a dispatch method, just like the store object. Following that, it maps over all middleware and calls them with the middleware API. Now you have an array of partially applied middleware called chain. They all have access to the middleware API because it has been supplied as the store argument to the middleware. This is what chain looks like, assuming you map over the middleware array that contains the logger and the thunk middleware. Note that the store here is the middleware API object. I've written one of the two examples here for the logger as an immediately invoked function expression so you can see what's going on. But note that the way that the thunk looks like is the correct way. The inner function of apply middleware then uses reduce write over these partial applications in chain to compute the latest version of dispatch called enhanced dispatch. Remember, middleware usually takes in a store, the previous dispatch usually called next, and then returns a new dispatch function that takes in an action as its argument. When using multiple middleware, each one takes in a next parameter, which is the dispatch function modified by the previous middleware in the chain. This lets each middleware wrap or change the dispatch behavior of the middleware before it in the chain array, or the original store's dispatch if it's the first middleware. You can use reduce write because middleware is usually written with the expectation that it will receive the action before any previously registered middleware handles it. This means middleware should be applied in the reverse order of how actions pass through them. Let's go through this step by step. First, it starts with the original dispatch function from the store. In the first step, the thunk middleware is the first to wrap around the initial dispatch using reduce write with a store captured in its closure. It checks if the action is a function and, if so, executes it. Otherwise, it proceeds. In the second step, the logger middleware is then wrapped around the dispatch modified by the thunk middleware. It logs the action and the state before and after the action is processed. Finally, the enhanced dispatch is now fully composed and incorporates both middleware. First, it logs the action's details, then processes thunks, and finally logs the updated state. The store remains accessible through the closure from the creation of chain. Apply middleware finally returns a new store object with the modified dispatch. Your createStore function should now accept a third parameter called enhancer. If the enhancer is provided, it returns and calls the enhancer first with the createStore function itself, then with the reducer and initial state. This returns an enhanced version of the store where the dispatch function has been replaced with the enhanced dispatch, which contains the middleware logic. The rest of createStore remains unchanged. Now let's briefly jump ahead and take a look at how you can use your new modified createStore function. You pass apply middleware as the third argument, and apply middleware is called with your middleware. Since apply middleware returns a function with the same signature as createStore, taking in a reducer and initial state and returning the store, this preserves the original behavior when middleware is applied. If you call the createStore function inside apply middleware without an enhancer, it functions normally. Middleware makes solving the logging problem easy. The logger middleware logs the current action and calls the next middleware in the chain. After all middleware has processed the action, it logs the store state and returns the result. The thunk middleware enhances Redux's dispatch function's capabilities by allowing you to either handle asynchronous operations or complex synchronous flows. If the dispatched action is a function instead of a regular object, the thunk middleware intercepts it and passes dispatch and get states as arguments to that function. Now define a simple root reducer that can handle an increment and a decrement action, and then set up the store with your middleware. Then dispatch some actions as objects and as functions. The function can be an asynchronous function too. When you run this example, you get the following output. The logger function logs out your actions and the state after each action, and you can see that there's a delay before the thunk executes its logic. The logger middleware captures all of the actions also dispatched by the thunk because both middleware process every action. And both middleware are available as packages, so install them. Redux also exports apply middleware, so import it with the middleware. Now you can modify your makeStore function to set up your middleware. When you now dispatch any action somewhere in your app, it gets logged out. And you can also dispatch thunks now. So, let's answer the questions teased at the beginning of this video. Why did Redux become so popular? Redux became popular because of the following properties. Redux gives you deterministic state resolution, ensuring consistent view renders with pure components. Given the same initial state and the same actions, you always get the same resulting state. And given the same props, you always render the same JSX. Every action in Redux can be treated as a transaction. The state transitions occur atomically, meaning either all actions get processed and the state gets updated, or your state remains unchanged. Redux keeps state management separate from side effects like API calls or time-dependent operations. Redux uses middleware to handle these operations, keeping your state management updates pure and deterministic. Redux gives you a single source of truth for your application state by centralizing your application state into one single store object. It also gives you easy state sharing between your components. With a centralized store, every component can access the global state without the need to pass props through your component tree. Using developer tools or middleware, Redux can log out all the actions and state changes. This allows you to understand the sequence of actions that happened to evolve the state over time so that you can debug your app. Finally, Redux gives you time travel debugging for easy state review. Because state updates in Redux are deterministic, that allows you to step back and forth through your changes to understand what happened. You will see how to do that in the 5th video of this series. But now let's talk about the downsides of Redux, or why Redux has become unpopular. The first reason is boilerplate. Redux often requires to set up and manage a lot of repetitive code for the actions, the reducers, and the selectors. The second reason is that Redux has a steep learning curve. As you've noticed when watching this video, there are many concepts like actions, selectors, reducers, the store that you need to understand to work with Redux apps. The third reason is that Redux requires you to manually manage state updates such as loading states or error states. Since Redux does not inherently manage these for you like other libraries, you need to take care of them, which can lead to bugs if you make a mistake. And lastly, Redux requires the manual resolution of race conditions and caching. In Redux, handling concurrent data fetches and ensuring the latest request does not override the results of a previous one requires careful management of action dispatches and state updates. Similarly, implementing caching to avoid unnecessary network requests needs explicit logic. To address many of these issues, server-state libraries like UseSWR or React Query have become hugely popular, and modern frameworks like Remix or Next.js eliminate many of these problems because they manage the state behind the scenes for you. It is still tremendously valuable for you to know Redux because, as I said in the beginning of this video, it is still the most used state management library by a large margin, so it will be tremendously helpful for your future job opportunities to know Redux well. Now, this video was very theory heavy, though the 4th and 5th video of this series will actually have you code real-world Redux example apps. But before that, you need to learn the most powerful middleware called Redux Saga, which is covered by the 2nd video of this series, so go watch that one next. Thank you very much for watching. I love you very much, and if you liked this video, give it a like and then subscribe to this channel for more advanced JavaScript content. Peace.